Over the course of the past 3 years, you've probably become really familiar with the term virus. And unfortunately, you've also probably become really familiar with the fact that these things, while they're smaller than cells, can have a global and worldwide impact. Now, typically when people contract viruses, we have antiviral medications that we can treat them with. But as we saw with this last pandemic, they don't always work for every single virus. These antiviral medications target the virus themselves. But what if we could somehow help the body fight viruses? So in order to do that, thank you, we need to understand how the immune system works. And it's pretty complex. So picture this: a kindergarten classroom at recess. Now, I don't know if you guys have spent a lot of time around little kids, but they love to just pick up random things that they find interesting, like sticks and rocks and flowers and whatnot. So imagine that one of these kindergartners picks up some poison ivy, mistaking it for a flower, and then goes and shows it to their teacher. Hopefully that teacher is going to be very alarmed and treat the student, as well as find out where the poison ivy is and get rid of it. Now, your immune system is really similar. Your white blood cells make up your immune cells, and there are a lot of them with a lot of different roles, but we're just gonna focus on two. Your dendritic cells, or DCs, are kind of like the kindergartners. Right now in your body, there are dendritic cells running all over your body, picking up all sorts of different interesting particles and proteins and showing them to T cells, which are kind of like the teachers. And then the T cells will respond if they notice something dangerous, like a virus. Now, not all dendritic cells are created equal. Kind of like there are a lot of immune cells, there are a lot of dendritic cells as well. And we noticed that the ones that happen to be the best at getting this response in clearing virus are ones that have this protein called T cell immunoglobulin and mucin domain 3. But for our purposes, we can call it TIM3. Now, TIM3 is expressed on a lot of different immune cells, but only on the DCs that are really good at getting this response in clearing virus. So we wanted to know two things. One, is this necessary and involved in viral clearance? And two, how does it do that? Well, we noticed that if we take these specific dendritic cells and we take TIM3 off of them, once they show a virus to a T cell, you get a much smaller response, suggesting that it is involved. So my research now focuses on looking at each step of the pathway and seeing how the absence of TIM3 affects how these DCs are able to pick up the virus, what happens when they're getting over to the T cell, and when they show it to the T cell. And what does this mean? This means that we've found something that can potentially help fight viruses. And once we understand how it works, maybe we can use it to create new antiviral medications. And hopefully next time we can stop a pandemic before it becomes a pandemic. Thank you.